Okay, this one is a little more challenging. It's also a little frustrating. So I'm actually going to do one of the ones that I have on my practice set, okay? On my practice set, this I believe is question number 15, okay? So I didn't do it the way I'm about to do it on the worksheet, but maybe this video will give you a little more clarity. The first thing we want to do is set one side equal to 0. So we're going to subtract 7 from both sides. When we subtract 7 from both sides, we wind up with 6x minus 5 over x minus 2 minus the quantity 7, which is now greater than or equal to 0, because 7 minus 7 is 0. So we have resolved step 1, okay? Now we need to identify the critical values. But this is going to be challenging because we do not have a common denominator here. We need this minus 7 to have a common denominator. We can identify the 0 of the denominator, but we can't identify the 0 of the numerator because the numerator is includes this. This minus 7 has to be somehow or another planned into the numerator. So watch what we're going to do. We are going to multiply, okay, negative 7 times x minus 2 over x minus 2. See, x minus 2 times x minus 2 equals 1. And we know that negative 7 times 1 is still equal to negative 7. But we have to give it a denominator of x minus 2. So we have to do this fancy algebraic maneuver here by multiplying it by x minus 2 over x minus 2. Now, when we do that, it's going to wind up, it's better to write it like this, okay? Minus 7 times x minus 2 over x minus 2. This is going to be a little bit cleaner. So it's better just to put the 7 with a parentheses, x minus 2, and then make it over x minus 2. All right, so what we're going to have here is 6x minus 5 over x minus 2 minus then 7 times x minus 2 over x minus 2 is greater than or equal to 0. Okay. Now we're going to be able to combine these two. They both have a common denominator, so we can combine them into a single fraction, which is what we want. So now we have 6x minus 5 minus 7 times x plus 2. And we're going to distribute that in just a minute, okay? All over common denominator, x minus 2. All right, now we're good. We've got a common denominator. Now we just need to clean up the numerator a little bit. I'm going to distribute the negative 7 times x, and then negative 7 times negative 2 is positive 14. So it's going to become 6x minus 5 minus 7x plus 14 over x minus 2 is greater than or equal to 0. Okay? Now we're going to clean this one up a little bit, and we're going to do 6x minus 7x. That gives us negative x, and then negative 5 plus 14, that equals plus 9, and it's going to be over x minus 2, and it's greater than or equal to 0. Now it looks like the first one we did in the last video. This is way easier to do. Now we just need the 0 of the denominator, the 0 of the numerator, and we can make our sign chart, okay? So the denominator, we're going to say that x minus 2 cannot be equal to 0, and so that means x cannot be equal to 2. So one of our critical values is 2, okay? This one, we're going to do negative x plus 9 equals 0, and if I add x to both sides, I wind up with 9 equals x or x equals 9. That's the same thing. So our two critical values are 2 and 9. So we're going to draw our sign chart, put infinity over here, put negative infinity over here. I'm going to put 2 here, and I'm going to give it the dashed lines, and then 9 over here. So remember, 2 cannot be a solution, okay? Now we just need our signs. Now, which of these equations are we going to use to plug in? Well, we can use this one. Okay, we can use our simplified equation. Okay, so we're going to plug in over here. We have 0 over here. So 0 plus 9 is 9. 0 minus 2 is negative 2, and 9 divided by negative 2, that's a negative. Okay. Now let's plug in something between 2 and 9. How about 3? Let's plug in 3. Negative 3 plus 9. Negative 3 plus 9, that's 6. 3 minus 2, that's 1. So 6 over 1 is 6. That's a positive. Now let's plug in something larger than 9. How about 10? Negative 10 plus 9, that's negative 1. 10, and then 10, so this is negative 10 because the negative belongs to the numerator, okay? We just put a 10 here and it became negative 10, but here it's just 10. 10 minus 2, that's 8. So we have negative 1/8, that's a negative. And so we have our sign chart. We are looking for greater than or equal to 0, which is this middle part here, greater than or equal to 0. So this is our interval right here. And so it's going to be, we're not going to include 2 because 2 cannot be included. X cannot equal 2. But we are going to go up to 9, and we can include 9. So we put a bracket, and that is our answer to this, rational inequality.